Hello, everyone. I believe I am live now. So, first of all, could you guys give me the confirmation that whether I'm clearly visible, clearly audible to each and everyone, those who are watching me live? And a very good evening to all. We will start our session within few minutes so that everyone will join. But in the meanwhile, if you have any sort of questions, anything you want to ask from me, please do write in the chat window. Side by side, I'll read all your chats and will try to respond your answers. In the first 5 minutes, I'll take few questions. Then I'll start the session, and after that, at the end of the session, again I'll wait for 5 minutes so that everyone whosoever have listened this session completely, if you have any sort of doubts with respect to the session part, you can ask from me. Okay. So a very good evening to all. Very good evening, Nishit. Can you confirm to me, those who are watching me live, am I clearly audible or not? Clearly audible, clearly visible, both of the stuffs. Can I get some confirmation? Meanwhile, people are joining. Yes. Okay. So I got the confirmation. Okay, perfect. Thank you so much, Rudra and Nishit. Meanwhile, people are joining. What I'll do is I'll try to share my screen, you know, and you guys can give me the confirmation that whether my screen is also properly visible or not. Perfect. I believe my screen is also visible to everyone. So I hope that you already have watched from my topic name itself, right? On the thumbnail as well as on the headline, that today's agenda is to talk about something related to bit manipulation. Very interesting topic and very important topic. And the good thing is, I haven't covered up this topic until so far. So, we will try to cover up this topic, very fresh content, which you will not see until so far in my channel, right? So, I usually try to create the videos or the live which I have not covered up until so far. So, here, if you will observe, those who will miss this live session or they want to see the recording again, those who are watching me live, maybe they want to do the revision again of whatever things I have covered up. So what you can do in the playlist, if you will go in this DSA using Python playlist, there also I have tried to attach this video, right? Crack coding interviews, master bit manipulation. Apart from this, because it's sort of interview prospective video, today's session, which will help you in order to crack good interview questions in the interviews. So I have also uploaded the same video in the FANG DSA interview series. So in both of the playlists, you will see that this same live is going on. Okay? So you will be able to get the recordings from both of these videos. Again, if you will go in the description of this video, right, there you will be able to find out the content which I will upload after the session. So if someone is looking for the class notes, that where I will be able to get that. So here, if you will observe, there is a list link which you will be able to see. uh, GitHub repo with code samples, which you will click here. And here I'll, after the session, upload all the material, whichever I am teaching in the live session. So you can grab it from there. Okay. You can download the files and you will be easily able to utilize that. So I hope that until so far, everything is clear. Please make sure to hit a like button, subscribe, and share these videos with each and everyone, whosoever is looking for this kind of content. With that, let's start our today's session. I believe we can start now. It's been 4 minutes. We have already waited. Let me take your questions in between. Um, so Nishit is asking something which I think is a question for everyone, not for him. Question regarding interview after giving best still got rejected just for few concepts in an interview. How can anyone remember everything? See, cracking the interview is a game of luck plus your hard work versus smart work, right? So only hard work will also not be I can say that if you will do only hard work, then you will be able to crack the interviews. It's not like that. Luck also plays a very important role in the interviews. This is the very first thing which I want to convey here. Second thing, answering your question that how can anyone remember everything, I don't think that there is any human being who will be easily able to remember each and everything. The good way, which I usually apply on my person, which I can tell you, is that try to write the things which you feel is something very crucial for you in terms of any of the content, whether it be a DSA or any other domain which you are trying to, get the knowledge about. So please try to write it down. Notion is a very beautiful tool which nowadays I'm using very very handy, because that is there in the mobile phone also. So what usually you can do is that, maybe if I'll just show you, right? So this is a Notion. You can easily install it, free open source tool. And try to write down your stuffs in the Notion. That will really help you in order to get the better understanding of the stuffs. If you feel like that there is something new thought which is coming up, then again you can use this tool. Try to get that knowledge, right? I'll show you, but yeah, I'll not go in very much depth. Maybe I'll try to create a separate video for the same, that how you can try to create the notes. Usually writing via pen and paper is also a good way, which I usually do. But the only bad thing in that scenario is that we can't take that pen and paper everywhere, right? We need something which, on the spot, if I have some thought, I can easily able to write. And I am very bad in remembering the things. I'm talking about myself. So I have a very bad, or you can say good habit of writing each and every stuff. Okay. So for example, this is something which I usually have. So in the main page, I have what is the YouTube task I want to do, what is the office task I want to do. I have personal task, book reading favorites, data science and AI research, and others. So basically, whatever things I have in my complete whole day, which I usually do, or I am involved in various things. So I have completely each and every page linked towards that. For example, let me just click on YouTube task. So it will open up the page which I want to do, right? So in this way, you have so many beautiful tools. Notion is something which nowadays I am using. So I find it pretty much easy because it's accessible from my mobile phone as well. So on the spot, when I'm traveling also, if I got some thought, I can easily write it down on that page. So please try to write the things in whatever platform you're comfortable with. I think everyone whosoever is, uh, doing multiple things also, they are not someone bigger. They are just writing it down and maintaining the stuffs very cleanly, so that they will be easily able to get the content at the point where they want to get, right? So this is important. So Rudra is asking, is your ML course is enough to start? So the ML playlist that I have on my YouTube channel is not, finished yet. There is so much content which needs to be uploaded further, and I'll definitely upload that. So if you remember, I have taken the poll in the community post. I hope you guys have filled that, right? So if you will observe here, I have taken the poll few days back. So 2 days back, I have taken the poll. So I got maximum, I would say, percentage in this questions part, DSA questions part. That's the only reason I am as of now conducting this session. But in future, definitely I'll go for this PCA part, which is a part in machine learning. So definitely we will do that as well. So it's not completed, but yes, it's good to start. And step by step, when videos will be coming up, then you can keep on utilizing the content simultaneously. It's not the end. Start is good, but ending is not there. So I have to finish that particular playlist, right? Let's get started with the bit manipulation part. Okay. So now the very first important thing is, what is the meaning of bits? Anyone who can let me know? What do you understand by bits? What is the literal meaning of a bits? If I'll say that I am dealing with a binary bits, binary numbers, so what does that mean? or let's say I want to convert any decimal number representation to a binary one. It's a bit manipulation task where we are trying to convert our numbers in the form of a zeros and ones. So that is the literal meaning, where we are dealing with zeros or ones. So 0 is also a bit, single bit, 1 is also a single bit. The question now is that why there is a need, first of all, to study this kind of concepts. Apart from interviews, okay, I told you that it is very much crucial in terms of interview perspective. Apart from this, why there is a need to, even do the conversion from decimal to binary, or, where in the real time, because I always talk about in every session that what is the real time application of each and every concept which we are studying. I think that's the biggest motivation for you all to, go in much more dive and attend the session of at least 1 hour. If I'll not give you the motivation, obviously many of them will leave. So the important thing to understand here is that why there is a need to understand this concept of bit manipulation. And in real world, where do you think that this kind of application is widely used? Anyone, any idea? Anyone, any idea? In a real world, where you think this bit manipulation kind of a concept is very widely used? First of all, whenever you're writing some code, maybe there is some complex program is given to you, and if you're writing the code in the bit manipulation form, meaning you're using some bitwise operators to do that code, it is quite efficient. It is quite efficient and fast. So the code writing in the bit manipulation logic is quite efficient and fast. What is the reason behind that? Because our hardwares are dealing with these bits only, right? So as Nishit already answered, yes, the real time application is that in lot many hardwares, the bits are only what we are using, right? Apart from this, any other? Very good. Rajkumar have answered it very much aptly. So if you will, I'm not sure that how many of you are aware about the concepts of compression algorithms, right? The concepts of encryption, where we are trying to encrypt our data, right? So in the compression techniques, wherever you want to compress your data, so there is a separate subject of data compression. I don't know how many of you are aware about that concepts, but yes, data compression. Again, there the techniques that we have, the algorithms that we have, they are completely based on the concepts of this bit manipulation. Apart from this, a lot many encryption techniques that we have, as already mentioned by Rajkumar, is again based on this bit manipulation. So these are the very widely used applications of this bit manipulation, and that's the real reason. If you will go in any of these domains, and if you have ever studied these concepts in maybe computer networks or in data compression per se at your college, you will be easily able to observe that so many algorithms that we have is completely based on this bit manipulation part. Makes sense? So that's why today it's very important to understand. Even I'm not sure that how many of the audience here is from data science domain. In data science also, whenever a complex algorithms we have, whenever we are dealing with any complex algorithms, and some research happened to uh, optimize that algorithms efficiently to make them faster, training happen internally, bit manipulation approach is something which every researcher is looking for, right? So in there are lot many applications, and whenever you want to fastly get the results, you by using the optimization per se, definitely bit manipulation is a very strong approach. Today I'll give you a lot many examples also, which we will cover up, so that you will be easily able to get the motivation that why there is a need to explore more in bit manipulation. Obviously within 1 hour of time, or maybe if I'll extend also within 1.5 hours of time, I can't give you a complete idea about bit manipulation. But definitely, if you will watch this session till the very end, and if you're with me till the very end, then definitely after listening from today's session, you will get the idea that definitely there is a need to explore more about bit manipulation. It's extremely important topic. but you will find a lot lesser content about this. But I feel in terms of DSA also, whenever you're going for an interviews, it plays a very important role. If you're making some logic without bit manipulation versus bit manipulation, the person who is making the logic via bit manipulation have more priority obviously to select as comparable to the person who is doing via other logics. So that is something which is very much important to understand. I hope it makes sense. So with this, let's try to move ahead with respect to the topics that we will cover up in today's session. I hope that the motivation is something which is already delivered to you all, that why we are studying this topic. Apart from interviews, as I said, that these are the applications that we have for the bit manipulation part. Now, specifically in bit manipulation, today I'll talk about the most important topics which I believe everyone should know, be it any domain. If you will say that I am from data science domain, should I have a knowledge about these things? If I am from web development domain, should I have this knowledge? Or if, let's say, if I am normal software developer, should there is a need to get that knowledge? Definitely, for all of them, today's session is required actually. So I am talking about only those topics in today's session within that time frame which are very very important and which helps you to grab maximum interview questions very easily. Okay, so we will try to filter down few topics today because we can't cover up everything, and whatever is very very important which I feel I'll try to cover up in today's session. Okay, so the very first thing is, which everyone should know, is about the operators. And in bit manipulation, there are two very important operators that we have. And what is the literal meaning of those operators is also something which we have to understand in today's session. So, very first thing which I'll talk about in today's session in lot more depth is about the operators. And in operators also, I'll specifically talk about two operators that we have. One is something I hope you must have heard about this, left shift operator, and another one is something which we called as right shift operator. So these two are very very crucial operators which you will feel in maximum questions, various questions you will be easily able to solve via the these kind of operators that we have. Now, what is the literal meaning of a left shift operator and the right shift operator? We will be able to understand via one example. Let's say I'll give you one number and that number is 4. Okay, now, the bitwise left shift operator is denoted by this symbol. And the right shift, because we are exploring towards right, is denoted by this symbol. Now, when I'm saying that I want to do a left shift of this number 4, so how will you do? I want to convert do my number 4 left shift by 1. So 4 left shift by 1. So how will you do this thing? Anyone who can give me the answer, who is already aware about this concept, that how we can do a left shift? Anyone who knows what will be the answer my code will give if I will do left shift by 1 of that number 4? Anyone who can tell me the answer? Let's see who can give me the correct answer. Anyone? Any idea? Okay. What is the binary representation of number 4? So Raj said multiply by 2, and that's actually very much correct. So I'll give you the core idea behind this. How he came to know about this, I'll give you the brief idea about that. First of all, before doing this, how many of you are aware that how we can convert any decimal number to a binary number? If I'll ask you that, there is a number 4 that we have, convert this number 4, this is a decimal notation, right? This is a decimal number. How we will be able to convert this decimal number to a binary number? So I hope I am expecting that everyone should know. If someone is not aware, I am letting you know. So what we usually do is we will try to divide our number by 2 and we will try to store the remainder. So 2 2s are 4, remainder is 0. 2 1s are 2, right? Now the remainder is again 0. Because the remainder value which I am getting now, the pending value which I'm getting now is 1, which is less than 2. So that's where I'll stop it here, and I'll try to store my answer from bottom to up. Means I'll go from here to here. So what I'm saying is that the binary representation of this 4 is 100. This is something which in terms of bit manipulation notation called as lowest significant bit. This is something which we call as most significant bit, MSB. So whenever I'll use these terms, don't get confused what is LSB and what is MSB. Least significant bit, most significant bit. Okay. Now the number 4 binary representation is, as you can see, 100. 100. Now how you can check it out that this number which is 100 is 4? Means vice versa, how we can do from binary to decimal if I want to convert, how we can do? So what you can do is you can say 0 into, you will start from 2 ki power 0. Again 0 into 2 ki power 1. Again 1 into 2 ki power 2. So what is happening? I am starting from the right extreme and moving towards the left side, incrementing the powers. And I will add all these terms. So what I will be able to get? 2 ki power 2 is 4 plus 0 plus 0. So what is the answer I will be able to get? I will be able to get the answer as 4. So this is how basically we will be able to convert decimal to binary and binary to decimal. Is this part is clear to everyone? I hope you must have done this thing in your lower classes as well, because these kind of concepts we usually have in our schools also, right? Do you remember that? Do you remember that, everyone? Can I assume that you already knew all these things? And I already have give you the revision also of these stuffs, how we usually do in our lower classes. Now, basically, if I am saying that you have to do left shift by 1, how will you do? See, what usually happens, the 4 is something which is you are saying 0, 1, 00, right? This is 4. Can I say this is 4? Now, what I want to do, I want to move my numbers towards left side. Left side. I want to shift one digit towards left side. So move ahead left side, 0, 0, and the last value is empty where you will denote 0 only, right? So now this is 4, right? Now when you do left shift by 1, you have placed your values towards left side, every bit towards left side. What value you will be able to get? What value you will be able to get? 2 ki power 0, 2 ki power 1, 2 ki power 2, 2 ki power 3. It is something which you're getting as 8. So those who have responded that it will multiply by 2, for example, Rajkumar and Rudra also said as 8, it's a correct answer. Can you see that? How we can do the left shift? I have shifted my bits towards left side by 1, by 1, by 1. So what answer I will be able to get? By doing a left shift of 4 by 1, I will be able to get the answer as 8, which is nothing but is a multiplication by 2. Can I say, everyone? Is this part is clear to everyone? Is this part is clear to everyone? Can I say? So always remember one thing now. I'm just giving you a generalized idea about the left shift operator, that in generalized form, whenever you are doing a left shift of any number, always remember that what you are trying to do is you are in a way doing a multiplication by 2. Always. In other words, you are trying to increase your number exponentially by 2, by 2, by 2, by 2, by 2. If I'll say that do the left shift of this 8, can anyone tell me what is the answer I will be able to get? If I am saying do the left shift of this number now, who will tell me what is the answer I will be able to get? Now you can tell me instantly also, right? You know what I'm saying. So if I will do the left shift of this number 8, what is the answer I will be able to get? Anyone who can give me the answer? Left shift by single digit of this number 8. The answer should be 16, because now one will move ahead. You will be able to get 4 zeros. So if you will just convert this number to a decimal form, the answer will be 16. So I hope that this part is pretty much clear to everyone. Is this clear? Shall we move ahead to the next important concept with respect to the right shift? Is this clear to everyone? Shall I move ahead to the right shift concept? Now, let's say I'm taking the same number. Number is 4. And what I want is, I want to do a right shift of this number by 1. What is the meaning of that? You know that number 4 is 100, right? Now, if you will do right shift, if you will move your number towards right, what is the answer you will be able to get? So this is 4. This is 4. If you will observe, your value will become 010. You have moved your bits towards right. So 0 will come here, 1 will go here, and at the end we will be able to get extra 0. Now, if I just try to convert this binary number to a decimal form, this is nothing but is equals to 2. Can you see this? This is something which is equals to 2. Now, what is the inference you will be able to get here? What is the inference can we make here? Can I say that whenever we are doing a right shift operation in a given bit, we will always doing a in generalized form division by 2. Division by 2. So now very important thing, a point to note here is that whenever we are doing a left shift, in generalized sense, we are multiplying our number by 2. Whenever we are doing a right shift by 1, in generalized sense, we are doing a division by 2. That's the first and the foremost important point which you have to take away from this session. I really want at the end of the session, you guys give me in the comment section what are the key takeaways which you have learned from this. And I think this is the very first key takeaway which you should learn from this. Or I should say it's a second one. First one is what are the real-time applications, because many of them are not even aware that what are the applications, why we are using bit manipulation. Second key takeaway is that what is the inference behind left and the right shift operators that we have. Is this clear? Rudra also mentioned in a very great way, which is again a very good way to write, but sometimes people get confused. That's why I don't write this heavy notation, but it's very much apt that whenever we are doing X left shift with Y, what we are internally trying to do, we are doing X into 2 key power Y, means we are doing an exponential increase. When we are doing X right shift with Y, as you can see on my screen also, what Rudra have mentioned, it's very much apt. X divided by 2 power Y, because we are doing a division by 2, right? This is the overall, I would say, conclusion which Rudra said is very much apt, right? Second key takeaway. Is this clear? Shall we move ahead to the next third important key takeaway from this session? Yes or no? Can I get some confirmation from everyone? So, as of now, I have talked about 2 operators. So, these are the bitwise operators. Okay? Because we are using bits here to operate. Until so far, we have talked about 2 operators, left shift and right shift. Now, I am talking about 2 more very important operators, which we will use very frequently in real-time, questions also. One is called as AND operator that we usually use. AND operator. The notation is this. One is something which is XOR operator, which you will use quite frequently. Notation is this. What is the truth table of AND? I hope that many people are aware about the AND operator. Even there is something which we have is OR operator, right? OR operator. So what is the truth table of these operators? Let's say this is the output that we have. Now these things I hope that you must have studied at any point of your time in your college or in your lower classes. I'm pretty sure that you have learned. You can't say that you didn't even have learned these things. But if you have forget about these stuffs, I'm giving you a brief idea about these things. And then maybe in the next important key takeaways, we will try to implement some real-time problems, interview problems, which can be asked from you and how you will be able to solve that, what techniques you can apply, and then we will do the implementation as well. Okay, this is how the flow will go. So let me give you a very simple truth table about OR and AND operator first. So OR says that let's say we will be having bits 0, 0, 0, 1, 1, 0, and 1, 1. OR says that at any point of time, if bit is set. Now, whenever I'm saying that any of the bit is set, set meaning that at any point of time you will be able to get the number 1 as a bit. This is something which we usually say in a algorithmic sense as set bit. Okay, so when I'm saying set bit, it means you always understood that I'm saying 1. So whenever you're getting the value as 1, the answer will always be 1. So answer will always be 1. Otherwise, answer will be 0. The opposite of this is and, which says that, let's say we will be having these values. It says that when both of them are set, then only my answer will be 1. Otherwise, my answer will always be 0. So my answer will always be 0. The only thing where my answer will be 1 is when both of the bits are set. Means when both the values are 1, then only I will be able to get the answer as 1. That's why in DSA, whenever we're solving any kind of a problem, and I hope you must have used at any point of time in a while loop, we usually apply and condition. For example, in insertion sort, we usually, whenever we are writing a code, we apply a and condition, right? So what we say is this condition and this condition should be true, then only this while loop will run. So these operators will make a very important sense in that scenario. Let's talk about this beautiful operator as well, which we call as XOR operator. What it says, please try to understand this operator as well. Very, very important in terms of interview perspective. I will let you know how. Okay? It says that whenever both the bits are same, the answer will always be 0. For example, in both the cases, because the value is 0, 0 or 1, 1, both the bits are same, answer is 0. But at any point of time, if any one of the bit is different, the answer will always be 1. Whatever be the another bit that we have, the answer will be that bit only. In generalized way, what I'm trying to convey you here is that if, let's say, you will be having one bit as A, and if you're trying to apply the XOR operation with the same bit, the answer will always be 0. But let's say if you're having A and you're applying a XOR operation with 0, then answer will be always A. This is the important conclusion that you always remember with respect to the XOR operator. What I'm saying, when the value of both the bits or both of the bits are same, the answer will always be 0. When you are applying a XOR operator, let's say you are having value as 1 and 1 XOR 0 will be 1. 4 XOR 0 will be 4. 7 XOR 0 will be 7. So whatever value you have, that value itself will be printed at the XOR. That's the complete inference that you can take from the truth table of XOR operator. This is the third takeaway from this particular session. So this is the third key takeaway from this session. Is this part is clear to everyone? This is the second one, second key takeaway. And this is the first key takeaway. Shall we move ahead now to the next very interesting part? So whatever knowledge now we have utilized until so far with respect to the bit manipulation part, we will try to utilize this knowledge in terms of doing a practical interview questions. That's a very interesting key takeaway. This is the fourth, you can say, key takeaway of today's session, which is quite interesting. So whatever knowledge we have gained so far from the last 30 minutes, now we will try to utilize that knowledge in order to solve our questions. Practical questions, which are practically asked in not many good product-based companies. Shall I start asking the questions now? Let's see who will be able to give me the logic, because now no one can say to me that, okay, I am not aware about the concepts, because I already have taught you the concepts. Then I am coming towards the interview problems. Very interesting point here in interview problems, which you will really enjoy now, because now you already have an idea about the core concepts. Shall we start with the very first question, which is very, very frequently asked in lot many companies? Let's see who will be able to give me the answer. Shall I start now? Okay. Please try to listen to the problem very carefully and then try to give me the response as and when I stop giving the question. Okay. So let's see who will be able to give me the answer on the very first spot. There are so many students who are watching me live. We will try to see whosoever is giving me the correct response for the very first time. I'll obviously highlight his or her answer. Okay, let's see. How many of you will be able to give me the correct response? It means that you have learned something out of it. Okay. So let's get started. I'm giving you one array. Okay. I'm giving you one array. Let's say this is an array that you have. So let's say the array contains the elements, and maybe the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, there are total 10 elements that we have in this array. And the elements are like this: 2, 4, 2, 4, 5, 6, 6, 5, 4. Let's say this is something that we have. Perfect. So here in total, we will be having 9 elements. Now, what I'm saying to you in this question, I'm saying to you that given an array, every element is appearing even number of times. There are duplicate elements we have in an array, as you can see. And what I'm saying is, every element, every duplicate element is appearing even number of times, except one element which is appearing odd number of times here. Okay? Meaning, here if you will observe, the unique elements are 2, 4, 5, and 6. 2 is appearing 2 number of times, 4 is appearing 3 number of times, 5 is appearing 2 number of times, 6 is appearing 2 number of times. In total, how many number of elements we have? 3, 5, 7, 9, which is correct, right? Only single element appears odd number of times. That element I want to print. Okay? I hope you got my question pretty well, right? So what I'm looking for is, I'm looking for as an output from my code is 4. Because this is the only element which appears odd number of times. So user will pass the array in such a way, user will pass the array in such a way that he or she will always get only single element which will appear odd number of times except all the elements that we have. So I already got the correct answer by Rudra. Very good. So he's saying it very much aptly. What he said is, we should perform XOR operation, I think. And that's the very much apt result. Very good. So here if you will observe why XOR operation makes much better sense in this particular question as comparable to all other operators that we have learned so far. The only reason is that here if you will observe, for the same number of elements that we have, for example, 2 is appearing 2 number of times. So when XOR, we will try to do 2 versus 2, as I told you in the properties, that the XOR with the same number is itself is always 0. So you will be able to get the answer as 0. Even with respect to this 5, same thing will happen. 5 XOR 5 will be 0. Even for this 6, same thing will happen. 6 XOR 6 will always be 0. Yes or no? Now you are left with a 4, right? So what will happen? 4 is appearing 3 number of times. 4 XOR 4 is 0, and 0 XOR 4 is, now you know that any number XOR with 0, according to the properties that we have just now learned, answer should be 4. And that's what I want to print. So what I will do, I will simply try to apply one for loop. I'll simply try to apply one for loop, right? Which will start taking the elements int num present in the nums array that I have. What I will do, I'll apply the XOR operation with respect to all the values that I have. XOR with respect to all the num values that I have. And finally, when I will return out of this particular for loop, what I will return, I'll return simply that XOR value. Means whatever with the left value which I have, I will be able to return that. And that's how you will be able to get the odd occurring element, odd frequency element, anything you can write as the function name, which is taking the nums array. So is this clear? What I'm trying to convey here? Yes or no? Can I get some confirmation? So simple, right? But now only that student will be able to understand this question, or that student will only able to get this approach pretty well, who knows that how we can utilize this property of XOR. So what I'm saying is, this for loop, what it will do is, it will take each and every number. So here I'm not taking a number via index number. There are two ways to apply a for loop. One way is you will go index by index. Here I am grabbing exact number itself. Okay. Now what will happen? It will take the number 2 firstly, then it will do XOR with 4, then XOR with 2, then 4, then 5, then 6, then 6, then 5, then 4. Now as I have mentioned, the numbers are same. For example, 2 and 2, 5 and 5, 6 and 6 will give the 0 answer. Then 4 and 4 is also 0. The only number which is left is 4. So 0 XOR 4 is 4. Very simple. What we are trying to do is, we are trying to do the XOR of all the values that we have. Now what will happen, as per the two properties that we just now have studied, the numbers which are very similar, the same numbers will get cancelled out, means they will be able to give me the value as 0. Then the only pending number with that XOR value with 0 will give me the answer as that pending number itself. Is this part is clear to everyone, what I'm trying to convey here? So if I'll ask you now, what is the time complexity of this approach? What is the, because every question usually judged by its time and space complexity. So if I'll ask you, what is the time complexity of this operation? Can anyone tell me? And what is the space complexity of this operation? What is the time and what is the space complexity of this operation? Anyone who can tell me? Pseudocode is there with you. If you will observe here, we are trying to apply one for loop, right? We are trying to apply one for loop, which will try to scan all the elements that we have in our array. So it is nothing but is equals to big O of n. What is the space complexity of this complete array that we have? Obviously, we are not using any extra space, so it will come out to be constant, big O of 1. Is that clear to everyone, what I'm trying to convey here? So what I can do is, I'll try to do the simple code for this, just to show you practically as well. So here I am doing in Java programming language, int air. If you want, you can do the same thing in Python as well, because I'm usually comfortable with both the programming languages. And from the past few sessions, I'm taking in Python. So many students are requested to be in Java as well. So today I'm doing in Java, okay? So let's say we will be having elements like 2, 2, 4, 4, 4, 6, 6, 5, 5. Okay, these elements we have. Now what we're supposed to do is, we're supposed to check the odd occurring element, odd frequency element. Let's say this is the function that we have. Okay, so this is where I have done the function call. Makes sense? Now obviously this function will return me one element, which is, I am saying it as a result, or you can say odd frequency element. So what I can do is, I can simply in my main method print this element. So I will say system.out.println. Here I will try to say the odd appearing element in an array is like this. You can give a proper space and then you can copy this variable. We can print this. Fine. Now the only task is to define this function, right? Public static int check odd frequency, where we will be having the array air. Now what we can do here, the only simple thing that we usually have to do here is to apply the XOR operation. So that element I am defining with XOR, we'll try to define it with 0. Now I will define one for loop int num in my add that I have, or you can define this as element also, ELE. Okay? So we are directly picking up the elements now. What we are doing is we are doing a XOR operation, XOR of that with that element. Now finally, when we will return out of this for loop, what we want to return finally is the XOR. So this will return me the element which appears odd number of times, which appears odd number of times. Make sense? So because we have made one single for loop, that's the reason we can say that for this particular function or this particular major code, our time complexity will come out to be big O of n, and the space complexity will come out to be big O of 1. So let's try to run this code. Run Java. And you can see the odd appearing element in an array is 4. It is coming up. Now let's say if I'll just change this number, I'll take 4 as the even number of times, but now 2 is at the odd number of times. If I'll just again run this code, run Java, what answer you're getting? Now you're getting the answer as 2. So I hope that you understood that this logic is working very perfectly with respect to whatever test case you want to apply. I'll share the code with you. At your home, you can apply with other test cases also. I believe it will definitely work for every test case because the logic is very much apt. That's the beauty. So if you know the operators pretty well, then only obviously you will be able to think about these operators. Otherwise, definitely there are multiple approaches we have to solve this question. But this operator will give me the fast result. That's the real reason why we are moving towards the bit manipulation approaches. Is this clear or not? Is this clear or not? Shall we move ahead to the problem number 2 of today's session? Problem number 2, shall we move ahead? So, the problem says that, let's say if I'll provide you one number. So you need to, this is a very simple problem. It's an easy level problem. Where I'm saying that if let's say I will provide you one number and that number is, let's say, maybe 16. Okay? You need to check that whether this number is a power of 2 or not. If let's say this number is a power of 2, if let's say this number is a power of 2, then you need to return the answer as true. Otherwise, you need to return the answer as false. For example, for this test case, the result should be true. But if my number is, let's say, 15, so it is not a power of 2, so the answer should be false. How will you solve this problem? Power of 2 meaning, I hope you understand. 16 can be written as 2 ki power 4. So this is a power of 2. That's why I'm saying the answer is true. But this is not, we can't write this number 15 in terms of 2 ki power. So that's where the answer should be false. So how will we realize that properties of bit manipulation to solve this problem? Anyone who can tell me? Rudra is saying doing right shift will help. Okay, how? Think over it. A very interesting logic is there. If let's say I'm talking about this number 16, try to write this number 16 in terms of bits, binary number. So 16 can be written as 1, I think 000, 0, 1, 2, 3, yes. 1 000, it is 16, right? What is 15? What is 15? What is 15? What is the binary representation of number 15. Can I say this is 15? First number is 0, remaining will be ones. Think over it. 16 is 0, 1, 2, 3, 4. Just now we have discussed how we can convert our decimal to binary and binary to decimal. 16 is this. Always remember the number which is less than that number will be just inversion. Wherever 1 is there, 0 will be there. Wherever 0 will be there, 1 will be there. So 4 times 1. Always remember, if number is a power of 2, if you will observe, if you will try to get the intuition, if you will do bitwise AND operation here. So what is the meaning of bitwise AND? If both the values will be 1, 1, then the answer will be 1, otherwise it will be 0. You will be getting here answer as 0. Always remember what I am trying to convey here. I am trying to convey that whenever any number is a power of 2, whenever any number is a power of 2, you will observe that only one bit is always set to 1. For example, the 16 is this. 32 is 1 followed by 5 zeros. Right? 8 is 1 followed by 3 zeros. So whenever any number is a power of 2, you will always observe this one pattern. You will always have one bit set followed by all the remaining bits as 0. And that number minus 1 will be the inversion of that. Means wherever 1 is there, 0 will be there. Wherever 0 will be there, 1 will be there. For example, this is a very good example which you can see. 1 is there, 0 is there. 0, 1, 1, 1. Always remember, whenever you will do a bitwise AND operator of any number with a number minus 1. And if you're getting a number as 0 after doing this makes sure that the number is a power of 2. Are you getting my point, what I'm trying to convey here? Are you getting my point, what I'm trying to convey here? If any number is a power of 2, then that number doing bitwise AND with the number minus 1 will always give you the result as 0. Think it intuitively. Take any example. 32, 31, do bitwise AND, you will get 0. 8, 7, do bitwise AND, you will be getting the value as 0. So what I'm saying is, any number, if it is a power of 2, and if you will do a bitwise AND with respect to that number with the number minus 1, you will always get the result as 0. Is it making sense to everyone, what I'm trying to convey here? So by applying the simple logic of this, you will be able to get the result as either true or false. So basically, if I'll go back and we'll try to show you the implementation for the same. So if I'll just comment this out, and in the same file, if I write down that code, what I'm saying here, let's say you will be having a number 32, right? You want to check. So you will apply one condition, check the number is power of 2 or not, the given number. If the condition is true, maybe I want to print the result as true. Otherwise, let's say in else case, I want to print the answer as false, right? This is what I'm saying. So what I will do here is, I'll try to define this function outside the main method. So I'll say public static boolean, because we want to return either true or false. Check power of 2, we will be having a number num. What we want to do here is, what I am saying, let's say the base case condition can be, the number is 0, then definitely it's not a power of 2. In that case, return the answer as false. Light is gone, but I believe my audio is there. It will come within few seconds. Please wait, okay? In else case, what we are saying? We are saying return. What we will do? We will do a bitwise AND operation with that number and that number minus 1, right? So what I am trying to do here is, I am trying to do a bitwise AND of this number, and I'm checking that whether it is equals to 0 or not. So we can have another bracket inside this. So if the number and number minus 1 is equal to 0, the result will be true, otherwise the result will be false. So if I'll just run this code and if I'll just show you what I'm getting as the answer, true. If I just change this number to, let's say, 31, which is not a power of 2, so what will happen? Once you run this code, you will be able to get the response as false. You can take it any number at whichever number is coming in your head. Try to apply this logic in each and every test case. This should run intuitively, mathematically. Because if you will see its binary representation of any number of power of 2, it will always be 1 followed by zeros, and that number minus 1 is 0 followed by all the ones. So when you do the bitwise AND, you will always get the answer as 0. That's the real idea about this question. Very simple. Here, if you will observe, we are just applying a single bitwise operator. So what is the complexity of this code? Obviously, it will be a constant one. So the time complexity is constant, as well as the space complexity is also constant. Is this clear to everyone? What I'm trying to convey here? Yes or no? Yes or no? Can I get some confirmation? I hope it is clear, right? Shall we move ahead to the next question, which is the last question for today's session? Question number 3, again very widely asked in lot many interviews. So as of now, you have seen the importance of XOR operation that we have learned, bitwise AND operation that we have learned. Third, shift operators. Now you will see the problem for that. Let's say if a user is typing some number, okay? For example, if I'll say the number is 15, just now we have seen that the number 15 binary representation is 4 times 1. Just now I have shown you. So what you're supposed to do, I'm saying that you need to tell me the count of the number of set bits. Count of the number of set bits. Count of the number of set bits, meaning how many ones are there in this binary representation. For example, in this case, the number of ones are 4. So your result should be, your output should be, it is equals to 4. So how will we solve this problem? How we will be able to get the count of the number of the set bits? Anyone who can let me know before I will tell you the logic? So in this question, I have shown you the utility of XOR operation. In the second problem, I tried to show you the utility of a bitwise AND operator. In this problem, I really want to show you the utility of the shift operators. So try to think it via the shift operators that we have learned in today's session. Can we do it? Can we try to count down the number of bits that we have? Yes. How? Always remember, whenever someone is asking you that how many number of set bits do we have, the best way is that what you can do is, okay, please repeat the question. So here I'm saying that a user will type some number, okay? The number can be anything, any integer number. What you have to tell to the answer as an answer is that how many number of set bits, means how many number of ones in a binary representation that number contains. For example, let's say 15 number is there. So the binary representation of 15 is 4 times 1. So how many number of ones are there? 4, right? I hope it makes sense now. So for example, if the number is, let's say, 4, so the binary representation of 4 is 100. So here the output should be equal to 1 because there is only single bit that we have. And with 1, 2, 4, and 8, and so on. No, I think vice versa we have to do. whatever you have said. See, what I'm trying to convey here, we have this, let's say, number as 15. So how will you count? What you will do, you will say that I will do a bitwise AND operation of this number with 1. With 1. So 1 is meaning is this. So what will happen? You will be able to get the 1. So what you will do? You will make one count variable whose value you will initialize with 0. And now you will increment that count with whatsoever value you are getting. So now your count value will become, from 0 it will become 1. It will become 1. Now what will happen? Because now you already have included this count in your this one in your count variable, what you're really looking for is, you want to get rid of this one, because now you want to count this one. So what you will do here? What you will you do here? Left shift or a right shift? You will do a right shift. You want to move towards right. So what you will do is, now you will do a right shift. So you will be able to get 0, 1, 1, 1. Now, again, what you will do? You will again apply this bitwise AND with 1, and again you will be able to get the next count value. So the count value will become 2 now. Right? Same thing you will do again. Now, you will repeat this task until your value of number, you will apply one while loop. Until your value of number will be bigger than 0, you will keep on repeating this task. So what is the task which I'm talking about? First task is to do a bitwise AND of that number with a 1. Second task, now you will get the count value. Second task is to do a right shift of that number by 1. So when you do the right shift, obviously that number you will try to, in a way, in other terms, decrease by 2, divide by 2, by 2, by 2, and so on. And you will keep on repeating this task until this number is bigger than 0. Is this making sense to everyone, what I'm trying to convey here? So now, again, you will be able to get the value of count as 2. Further, again, you will do a bitwise, right operation. Again, you will do a bitwise AND. You will be again get the answer as 1. So now your count value will become 3. Again, you will do the value of this number by right shift. You will be able to get the answer as this. Again, you will do the bitwise AND. You will be again get the answer as 1. So your count value will become 4. Now when you will do the bitwise, right shift of this number, you will be able to get the answer as 0. That's where your while loop will get stopped. It means that the final answer, final number of set bits will be equal to 4. So in other words, what I'm trying to convey here is, if I'll just now comment this complete portion. What I am doing here is, I am saying, let's say we will be having a number 15. Now, what I am trying to look for is the count of the set bits, right? Count of the set bits. I will pass this number and I'll store the result, store it inside one variable called as result. Finally, I'll print that result. System.out.println the count of the number of set bits. Set bits meaning number of ones that we have. And then we can display the result. So here, let's try to define this method now. So public static int count of set bits, int number that we have. Now what we are doing here is, we are defining one variable called as count, which is equal to 0. Now we are saying, until my number is bigger than 0, do two stuffs here. First stuff is to count the value. So count is equals to number, do the bitwise AND with the 1. Then do the right shift by 1, that number. Finally, once you will move out of this while loop, return the value of the count. That is the answer, which will give you the number of set bits in a given number. So now if you will run this code, just check this. What you're getting, number of set bits is 4. If I just change this number to maybe 5, now the binary representation of 5 is 101. The number of set bits are 2. So your answer should come as 2. So let's run this again. The answer should be 2, which is very much apt. Now here if you will observe, you are using a right shift operator whose major inference is in a way division by 2. Means you are in a way divide your number by 2 by 2 by 2 by 2. So if how many times this while loop will run? By 2 depending upon that number value. The series belongs to something called as logarithmic series. So the time complexity of this particular code is big O of log of n. The space complexity, because we are not using any extra space, will come out to be constant, big O of 1. So why log of n? Because how we can calculate the complexity? How many times we are, running this statement of inside the while loop. So because we are trying to divide our number by 2 by 2 by 2, it will run until I will move to my value, which is bigger than 0. So that many times it will run. So that is why it is logarithmic, right? So this is how the complete flow should go. So this is the overall idea and the objective of today's session, to talk about the operators. These operators are very, very crucial. And with respect to every operator, I have tried to take the interview questions, which I feel is very, very important in order to get a better understanding of the same. Again, this is not enough. I hope this is a starting point of bit manipulation. Now maybe if you will go and check it out, the problems on lead code platform, I think you will be able to solve many problems after utilizing this session, because now you know the beauty about XOR, bitwise and, bitwise or, left shift, right shift operators pretty well. So I believe that maximum questions, if you will observe in bit manipulation, will be solved by these logics itself. And I hope that you will be easily able to get the idea about now why and how the bit manipulation operators are very much important and crucial to solve the problems, right? I hope that this session gives you a great perspective that how you can apply the logic of this bits manipulation part in any of the interview problems, wherever you feel like that, okay, I can apply division, multiplication, wherever these kind of stuffs are there, you can always open to apply this right shift, left shift operators. Wherever someone is finding out to find the missing values, you can apply that XOR operation. Wherever you feel like that both the conditions are necessary, you can go and apply the AND operator. Wherever you feel like that any one of them is necessary, you can go and check it out, the OR operation. This is how basically the things will work. So is this clear to everyone? Now I will wait for a few more minutes. If you have any questions, you can ask. Otherwise, I'll try to attach all these topics. I'll try to upload these topics on my GitHub repo. And as I shown you that in the videos part itself, sorry, in the live, if you will go in this particular video, you will be able to see in the description, I have mentioned the GitHub link. You can go and grab the resources of today's session from that particular link. I'll upload this after the session, and then maybe you can check it out, the code files plus the notes that I have written it down. So if you have any sort of doubt, any sort of feedback, any concerns, you can ask from me. Otherwise, we can wrap up the today's session. I hope that you find it very insightful. Yes or no? Please do share these videos. I genuinely need your support in order to reach to maximum students via this channel. So please do a favor with respect to that part also. And I believe we are good to go. If you don't have any questions, shall we wrap up then? Yes or no? It's been 1 hour, 10 minutes. I'm just speaking and speaking and speaking. Perfect. I think there is no as such doubt you can have. So thank you so much, everyone, for joining in. I hope you find these sessions insightful. You can give feedback with respect to that in the comment section also. And please try to share the key takeaways which you have learned from this session in the comment section so that it will help the other audience. See, these sessions are very long, so many people don't know what we have covered up. So these will be helpful. Your key takeaways will be helpful for them as well, to get the idea that whether they really have to watch these sessions or not. Okay, so that's the core idea of writing down in the comment section. And this is what all about in today's session. Bye bye, everyone. Thank you so much, everyone, for joining in. Bye bye. Happy learning. Take care and see ya.